Any other questions? If not, I have three. Question one, I saw that bottle over there, but I'm just wondering, is it possible? I mean, is it possible now to apply this into, say, like in public areas, say, like in public transport, in bus, or in buildings, because we see a lot of those things.
Because like when we did in the hospital, we do two model. Okay, number one is a spray type, because at that time they were interested in a fumigation or spray type applications. Like for example, if a ward had a sudden outbreak, they can come in and then vacate the ward and then do a fumigation and then use this as a fumigant. So we basically designed that for them, okay? And then the other thing is they were quite concerned, like for example, in application in a high-risk area, they don't want anything that is floating in the air. So we actually designed a wipe for them, okay? So it come in two different forms. More recently, like for example, when we got contacted by other company, so we were starting to look at the, like for example, non-woven fabrics. Hygienic fabrics like diapers, masks, the N95 masks. Because one of the major issue 3M kind of share is that if there's a major outbreak, okay, they cannot actually meet the demand. Okay, so it's very important for them that the mask should have a longer use time or can be reused. And then secondly, if a mask have a disinfecting action, because a lot of time the doctor get infected when they put on and remove the mask. And then a lot of the masks had to be fitted, okay, in order for it to work properly. So a lot of time there's a limited stock, okay, that will be available for the doctors. So they were quite interested in this. Now, other area is like the doctor themselves like kind of approach us and say, okay, you did the surface, but the other major route for this type of problem is actually through the air. So we are then working with them for HEPA filters, filter media, okay, for those type of applications. So that and we did a study also on filter media for airborne bacteria and molds and other materials. Okay, so I didn't include that because it would be too long.
What I meant is that a lot of times nowadays we go into a building.
Yes.
These elevators. They have.
I know.
I know. Disinfect it once every hour.
Yeah.
If you do a coating like this on it, would it last a lot longer or?
Okay, it can last very long because this is how we know that. Okay. Because when we test it, one of the tests is actually in the university in the computer barn. And then we basically coat the keyboard and the mouse. And then we did it during the close to the exam period when the barn is open 24 hours and the computer is used out of that 24 hour for at least 12 hours. And then there are at least 22 users. And then if you are using mouse, you are always constantly touching it. So that is what we do a model. It will be even more frequently touched than the lift button. Okay, so that is how we did the study. Okay.
Now, two other points that I'd like to point out before I ask. Now, one is that we have two patent experts here. I think patent your stuff.
In fact, this one we filed in a provisional, but now we went into the actual patent phase. The U.S. examiner is starting the examination. And then this is also filed for Korea, India, China, Japan, and then Australia, as well as European patent. Because there was an interest even from UK. We were approached by the Scottish government because they were interested in the technology and they wanted to come up with some collaborations.
And I want to ask the final question. There are a lot of influential people here today.
Yes.
Now, is there anything you need that would require the help of others, to help you to further this innovation?
I think one thing that we wanted is like more conversation. It's a continuing conversation because like every time I talk with different people, the one thing that I would say is like I learn more. Okay, because like we may be looking at the application only at the one narrow area. Okay, but there are probably other broader application for this system wherein it can help more people. Okay, Like for example, when I was talking with some people that are on volunteer, the first thing they said, "Hey, can we use it for refugee tents?" Okay, because in the refugee they have the tents, and then they have in very bad situations and then all those kind of stuff. So we talk with the ambulance, like the people. Oh, can we use it in the ambulance? Okay, but the temperature is this and that. Okay, so we were. So once you start a dialogue, it gives us some idea, okay? Because in our case, like support is important, but for us, it's like coming to us with a problem. Because a lot of time it's like many things that that excite our interest are actually real problem, okay? That come from industry or come from like students, okay? Wherein that kind of excite an interest for us, because like for us, like we look at it as a challenge to look at it, okay, and get the undergraduate to do it because they don't know that it cannot be done, okay. So a lot of our technology are done that way, okay. So thank you.
I promise everybody that we can leave here before 2:15, and then we are getting very close to that moment. So I have to thank the professor for coming to enlighten us on this new thing that never even thought about. But I'm sure the professor will be happy to stay behind for anyone who wants to have further questions on him on this technology. And on behalf of HKUST, I wish to thank everybody for coming here today. Just do us 2 favors: spread the word out. Say how nice this lecture is. And the next thing is write down what you truly feel about it and let us know so that we can know how to improve on it next time. Thank you very much.